MS Ramaya University of Applied Sciences.
Hello students, let us have a discussion on verification of truth tables of AND, OR, NOT, NAND, NOR and Exor gates. The aim of this experiment is to verify the truth tables of AND, OR, NOT, NAND, NOR and Exor gates. Motivation to this experiment. Digital electronic circuits are usually made from large assemblies of logic gates. Gates are used to realize electronic representations of Boolean logic functions. Representation of voltage or current variables in binary helps to reduce noises and make circuit implementation easy in communication systems. Let us understand the theory behind the experiment before conducting it. AND gate. It performs logical multiplication operation. It generates output signal of 1 only if all the input signals are 1. OR gate. It performs logical addition operation. It generates output signal of 1 if any of the input signal is 1. NOT gate. It performs complementation operation. It generates an output signal which is the reverse of the input signal. It's known as an inverter because it inverts the input. It's complemented AND gate. Output of the NAND gate will be 0 if all the input signals are 1 and will be 1 if any one of the input signal is 0. NOR gate. NOR gate is a complemented OR gate. Output of the OR gate will be 1 if all the inputs are 0 and will be 0 if any one of the input signal is 1. XOR gate. It performs the Boolean function A XOR B is equal to A dot B complement plus A complement dot B. To conduct this experiment, we need digital IC trainer kit, patch cords and ICs. IC 7400 NAND gate, IC 7402 NOR gate, IC 7404 NOT gate, IC 7408 AND gate, IC 7432 OR gate, IC 7486 XOR gate. Figure shows pin diagrams of all the ICs used in this experiment. Experimental setup includes ICs placed on digital IC trainer kit. Connect pin number 7 to ground and pin number 14 to plus VCC. Connect input pin to input switches and output pin to output indicator. Apply the inputs as 0 and 1. Observe the corresponding output as LED on or off. Figure shows the experimental setup for the verification of truth table. Figure shows the logic diagram and truth table of each ICs. Limitation of the experiment. ICs may get easily damaged with a reverse or wrong connection.
Hello students, name of the experiment is to verify the truth tables of AND, OR, NOT, NAND, NOR and Exor gates. Aim of the experiment is to verify the truth tables of AND, OR, NOT, NAND, NOR and Exor gates. Components required for the experiments are digital IC trainer kit. This is digital IC trainer kit. It is used to connect ICs. So it has 1, 2, 3, 4 IC slots. So we are using any one of these. So this is a one IC slot. Here we can mount the ICs and we can lock this by using this IC locker. And whenever you mount the IC on this, the pin number 1 should be mounted or one should be inserted this slot or a first slot. Whenever you insert the pin number 1 here, this terminal will be pin number 1, pin number 2, pin number 3, pin number 4, pin number 5, pin number 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. And for every IC we need a ground and a VCC, which is also provided in this kit. So this is a ground and this is the VCC. And here are the some terminals which are used to connect inputs to the any ICs. So here are the knobs. By using these switches we can make input either low or high. Low means 0, high means 1. If I make it down, this is a low, it's called 0. If you make it up, it is called a high or it is 1. And similarly here some terminals are there which are called logic outputs. Wherever you want to connect output of any IC, if you want to connect output, connect to this terminal, and whenever output is 1, the corresponding light or LED will glow. If it is not glowing, then output is 0. Patch cards. These are patch cards which are used to connect different terminals on a digital IC trainer kit. And ICs. These are all digital ICs. All ICs are 14 pin ICs. So one IC is for AND gate, one IC is for OR gate, one IC is for NOT gate, one IC is for NAND gate, one IC is for NOR gate, one IC is for Exor gate. On top of each IC numbers are written. Based on IC numbers, we can call them either AND, OR, NAND, NOR, NOT or Exor. For example, if you take one IC like this, on its top you can find a number called 74, then 2 characters, don't read that, 2 digits, 7400. So this is a 7400 IC. And if you see this IC, it has totally 14 pins, one side 7 pin and another side 7 pin. On its top you can see a notch. Left side of the notch is called pin number 1, 2, 3, 4, 5, 6, 7. So one side it has 7 pins, that is 1 to 7. Opposite to pin number 7 is 8, 9, 10, 11, 12, 13, 14. So this is pin number 1, opposite to pin number 1 is pin number 14. This is pin number 7, opposite to pin number 7 is pin number 8. Let us start the circuit connection of a AND gate, OR gate, NAND gate, NOR gate and Exor gate one by one. This is IC number 7408, which is AND gate. Based on IC diagram, we will do the circuit connection. First to verify the truth table of AND gate. So 7408, I will take IC 7408, which is AND gate. So I will connect in a IC trainer kit. So this is the IC mounter. So there is a notch. This is a pin number 1. So I will mount on this slot such that the pin number should go in a first slot. Then I will lock it. Now this is pin number 1, pin number 2, pin number 3, 4, 5, 6, 7. So this IC has only 7 pin one side. So 7 up to this, it is connected. So this is not a 8 because we are not connected any pins to this slot. So opposite to 7 is 8. This will be 8, 9, 10, 11, 12, 13, 14. Based on the given IC diagram, 7408 AND gate which has 4 AND gates. Now we will verify any one gate. For example, verify the first gate where pin number 14, this is a pin number 14 is connected to VCC. Take a patch card, connect to pin number 14 which is connected to VCC, and take one more patch card. So pin number 7, so here pin number 7 which is connected to ground, here is a ground, and pin number 1 is connected to input for a one gate. So this is pin number 1, here are the inputs, I will connect to input, and pin number 2 is connected to one more input as AND gate has 2 input. So pin number 2 I will connect to one more input, and pin number 3 is connected to output. So this is a pin number 3, I will take a patch card which is connected to output. Here are the output, you can choose any one. So let us take this output, I will connect here somewhere. Let's take here only. Okay. So now I have chosen one AND gate, 2 inputs and one output. So turn on the IC trainer kit. So now we will verify the truth table of AND gate. Now both input 0, 0. Low means 0, 0, 0. output is 0, which is not glowing. Whenever LED is glowing, it is 1. If it is not glowing, it is 0. For 0 0 input, output is 1. I will make 0 1. 0 1, output is 0. Now apply input 0 1. I will make this 1. Again LED is not glowing, so output is 0. Next we will apply 1 0. So first input I will make 1, next input 0. Again LED is not glowing, output is 0. We will note down this. Now we will make both input 1 1 1. When both inputs are 1, output is 1. So I will note down this AND gate. So this is the AND gate truth table verification. Similarly, we will verify the OR gate. So before going for OR gate IC connection, turn off the trainer kit. Again remove all the wires. Remove this AND gate. This IC number 7432, based on the circuit IC diagram, will do the circuit connection. So let us take a OR gate. It is 7432. This is a 7432 IC. So this is a pin number 1. I will connect to this first slot, lock it. So based on the given IC diagram, VCC is connected to pin number 14. So this is pin number 14, and 7 is connected to pin number 7 is connected to ground, which is ground, and 1 and 2 are the inputs. So I will connect pin number 1 to input 1. Next pin number 2 is also input. I will connect to second input, pin number 2, and pin number 3 is output. So I will take one patch cord, pin number 3, connect to outputs. So we have 2 inputs and 1 output. Now turn on the DC digital IC trainer kit. So let us verify truth table of OR gate. So for input 0 0, output is 0. Now we'll make 0 1. This is 0 1. Output is 1. That is light glowing. Now we'll make 1 0. So 1 0. For 1 0 input, output is 1. Now we'll make both 1. Both inputs 1 1. That is 1 1. Output is 1. By this we are done with the verification of a OR gate. Turn off this digital IC trainer kit. Remove all the wires. Remove all the wires and remove the IC. This is a NOT gate whose IC number is 7404. Based on the IC diagram, we will do the circuit connection. Now I will verify the truth table of a NOT gate. NOT gate IC number is 7404. I will take a 7404 IC. So notch, this is notch, pin number 1. So I will insert in I will mount on IC trainer kit and I will lock it. So for this, again pin number 14 is VCC. We'll connect here. So 14, which is connected to VCC. Pin number 7 is ground. Connect to ground. And for NOT gate, only one input, only one output. So based on IC diagram, pin number 1 is a input. I will connect to this input, and pin number 2 is a output. I will take a patch cord and connect pin number 2 to output. So we have one input and one output. Now turn on the IC trainer kit. So for input 0, we are getting output as 1. If you make input 1, output is 0. So note these values in a given truth table. So by this we verified the truth table of NOT gate. Turn off the power supply, remove all the connections, remove the IC. Now I will verify truth table of NAND gate based on the NAND gate IC diagram. So 7400 is a NAND gate IC. I will take a 7400 and mount on a digital IC trainer kit such that pin number 1 should go to first slot, and I will lock it. So based on IC diagram, pin number 14 is connected to VCC. Pin number 7 is connected to ground. Pin number 1 is connected to input. Pin number 2 is connected to one more input, and pin number 3 is connected to output. So this is a connection for a NAND gate. 2 inputs, 1 output. Now turn on the IC turner kit. So we have 2 inputs. So first we make both input 0 0. For input 0 0, output is 1. Next make input 0 1. For input 0 1, output is 1. Next to make input 1 0. For input 1 0, output is 1. Now make both input 1. For inputs 1 1, output is 0. So all these values we note down in a truth table. So by this we verified the truth table of a NAND gate. So turn off the IC turner kit, remove all the patch cards and remove the IC. This is IC number 7402, which is NOR gate. Based on IC diagram, we will do the circuit connection. Let us verify the truth table of a NOR gate. NOR gate IC number is 7402. We will take a 7402 IC and mount an IC turner kit such that pin number 1 should go to first slot. So based on the IC diagram, pin number 14 is connected to VCC. Pin number 7 is connected to ground. And for NOR gate, pin number 2 and 3 are input, so I will connect pin number 2 to input. Similarly, pin number 3 to one more input, and pin number 1 is output. So pin number 1 I am connecting to output. So now we have 2 inputs, 1 output for a NOR gate. Now turn on the digital IC turner kit. Let us make a input 0 0. For input 0 0, output is 1. Make input 0 1. For 0 1 input, output is 0. Make input 1 0. For 1 0 input, output is 0. Make input 1 1. For input 1 1, output is 0. Turn off the IC turner kit and remove the patch cards and ICs. This is IC number 7486, which is XOR gate. Based on the IC diagram, we will do the circuit connection. Let us verify the truth table of a XOR gate. XOR gate IC number is 7486. So this is 7486 IC. I will mount on IC turner kit such that pin number 1 should go to first slot. So based on IC diagram, pin number 14 is connected to VCC. Pin number 7 is connected to ground. And pin number 1 is input. Pin number 2 is input, and pin number 3 is output. For XOR gate, I have connected 2 inputs and 1 output. Now turn on the digital IC turner kit. So for input 0 0, output is 0 1. Sorry, for input 0 0, output is 0. Now make a input 0 1. For input 0 1, output is 1. Now make a input 1 0. For input 1 0, output is 1. Now make a input 1 1. For input 1 1, output is 0. By this we have verified the truth table of a XOR gate. Turn off the IC turner kit, remove the patch cards and remove the IC. So by this we have finished the verification of truth tables of AND gate, OR gate, NOT gate, NAND gate, NOR gate and XOR gate.
At MSR UAS, we spark your imagination unlike any other.